The purpose of this video is to do some preparation on our working data set that is necessary because the NHANES survey uses what's called a complex sampling design. It means that it's not a simple random sample, but rather it's called a stratified sample. Now, I would recommend, to get a little more depth in your understanding of these issues, that you read the NHANES tutorial Survey Design Factors section. This is modules 10, 11, and 12. And that will give you a more comprehensive introduction. But briefly, in the video on precision and bias, we saw this view. And this represents drawing a sample from the target population. And the target population here is the non-institutionalized US population. And in this view, we were looking at a simple random sample, which means that all of the people in the target population had an equal probability to be selected into the sample. Now, when you have a simple random sample, then you can use least squares estimation to find an unbiased estimate of the parameter in the target population that you're looking for, the beta value that you're looking for. But if different individuals in the population have a different probability of selection, then least squares estimation will become a biased estimation method. And so you have to go to what is called weighted least squares estimation for linear regression and weighted maximum likelihood estimation for logistic regression. Now, there are a couple of reasons why the NHANES data were generated using a sampling scheme in which people had different probabilities of selection. Now, for a complete treatment of this, you can look at the NHANES tutorial. But one of the important ones is that for some subpopulations in the United States population, they oversampled people. For example, in some survey years, they oversampled people who had low income. And in other years, they oversampled certain minority race populations. And the reason they did that was so that they could get good precision in the estimates for those subpopulations. But since some people had a higher probability of selection, we can no longer use the straightforward maximum likelihood estimation to estimate the parameters in the target population without bias. So fortunately, it's very easy to ask the statistics software to give us weighted estimates, but we have to set up our data properly in order to get the proper estimates out of the statistical program. So that's what we're going to be doing here. So one thing we have to do is find an appropriate weight variable for our particular analysis. And there are a number of different weight variables found throughout the data, so I want to first show some of them to you. So if you go to the questionnaires, datasets, and related documentation section, and my data are 2007 to 2010, so I'll look at the first of the 2007 to 2008 data. And in the demographics data set, in all of the cycles, you will find that there are two weight variables included, and they are these two right here. So this is the full sample 2-year interview weight, and this is the full sample 2-year MEC exam weight. And as you remember, in this data set, there's also a variable that's the interview examination status, RIDSTATR. And if we click on that one, and this indicates whether the person only had the household interview, there were 387 in this particular cycle, versus they had both the interview and the examination in the MEC. Most of the people had that. So there were a few people who, although they were interviewed in their home, they didn't go to the mobile examination center. And the two weights down at the bottom relate to these two groups of people. So if we were to draw this, we start out with some group of people who have the interview in the home. And most of them, but not all of them, also come to the mobile examination center for the examination. And so the full sample 2-year interview wait is for the larger group of people who had the interview, and the full sample 2-year MEC exam wait is for those people who had the MEC exam in addition to the interview. Now we'll look at this more carefully in a little bit here, so it will become clear. But first, let's look at some other weight variables that are available in the data. You'll also find a number of weight variables in the laboratory data. And you'll find weight variables for those laboratory analyses that were done only on a subset of the sample. And for most of them, you will notice that they actually have the word subsample in parentheses in the data file name here. So for this one, environmental pesticides subsample, this group of pesticides were only measured in a portion of the sample, usually a half or a third of the sample, randomly selected. So if we click on this, we can see that inside here there is also a weight variable. This one is called the environmental B 2-year weights. And they have different environmental chemical groups, environmental A, environmental B, etc. And so in each group there was a random sample, and a number of different environmental pollutants were measured in that subsample. So I don't know if this was a half or a third. Let's see if it tells us. So here it is. Here it is under the analytic notes. So the subsample weights, it says the measures of urinary environmentals were measured in a 1/3 subsample of persons 6 years and over. So they took a third of the people age 6 and over, and they only did the laboratory analyses for these urinary environmental compounds in that 1/3 subsample. And that was due to the cost of those analyses. So going back to this diagram, if we were going to use the environmental B 1/3 subsample, which would be about a third of the individuals, and I think they all went to the mobile examination center because that is where they drew the blood sample. Looks like I've drawn it a little bit big here. That's more than a third probably, but that's about a third of the MEC individuals who were randomly selected. So if we were going to be using a variable out of this subsample, then we would be using the environmental B 2-year weight. So in addition to the ones that say subsample in the title, I know of one at least that was a subsample, but it doesn't have the word subsample in the title, at least for this cycle. And that is for the plasma, fasting glucose, and insulin. So if we click on this one, we'll see here that there is also a subsample 2-year MEC weight. So this is for the fasting subsample. So this is a group of individuals who were required to fast for a number of hours prior to their analysis. And so this is so that you can get a good measure of their insulin and glucose baseline levels, which can be used to determine if they have insulin resistance and in the extreme diabetes, for example. So now we're at a point where each of our analyses is going to be a little bit different. And you will remember in the Excel files that we created that I asked you to mark down which subset of participants were included for each of your variables. So in my analysis, for example, here we have the baseline FVC. I wrote down that these were individuals aged 6 to 79 years who attended the mobile examination center. So what we're looking for is we're actually looking for the smallest group for any single variable that's going to be included in our model. And that's the weight that we're going to use. So in my analysis, I have most of them were collected in the MEC. A few were collected in the interview. I don't have any of the 1/2 or 1/3 subsamples, for example, the fasting glucose and insulin or the environmental chemical subsamples. So the smallest group in mine is the MEC. Now, you should do the same analysis for the variables that are in your model and find out what the smallest group is. Now, some of you might have written MEC here, for example, if you had an environmental chemical variable in your analysis, because those were collected in the MEC. And maybe you didn't notice that it was a subsample of the individuals who went to the MEC. So you should double check that you've written the right thing here. And if you have one of those subsamples, then you should change it to, 1/3 subsample or something like that. It doesn't really matter how you indicate that, just so that you're aware of what you have in your model. So let's look at how I'm going to handle preparing my data, given the fact that the smallest group that I have are the individuals who went to the Mobile Examination Center. So here I am in SAS again, and I'm looking at my create working data SAS code again. And the first thing that I'm going to do is I'm going to save this as a new version number, because I'm going to change things here. And if I mess things up, I want to be able to get back to where I was before. Now, the first thing that I'm going to do here is that you'll remember my analysis on the effects of smoking on lung function and chronic obstructive pulmonary disease was limited to individuals who were aged 20 or over, because that was the age group for whom the smoking questions were asked. But what we're going to do now is we're not going to limit the data set in the way that we've already done. So you can see here, this is where I limited the data set to those aged 20 or over. RIDAGEEX is a variable, the age in months. So 240 months is equal to 20 years old. And I limited my working data to those aged 20 or over here. The first thing that I'm going to do here is I'm going to get rid of this code, because we're actually not going to do it this way. So let me explain how we're going to do it. So the way the data are organized here is that there's some group of people who had the interview only. And there's a smaller group of people who, in addition to the interview, they also went to the MEC. Now, I'm going to be using the weight associated with those individuals who went to the MEC. And so the point here is that with the weight variables, when you choose your weight variable, you have to include all of the people who have a value for that particular weight variable. So for me, since I'm using the MEC weight variable, I'm going to have to include all of the individuals who have a value for the MEC weight variable. If I was using the interview only group, which is a larger group, then I would have to have everyone who had a value for the interview only weight variable. Now, if I was including a variable from one of the subsamples, for example, the urinary environmental contaminants, the 1/3 random sample of individuals who went to the MEC, then my data set would have to include all of the individuals who had a value for that 1/3 urinary environmental contaminants subsample weight variable. So for me, it's going to be the MEC group. Now, let me get rid of this other part here. Let's see if I can do this. Yes, I can. So these are the individuals who are going to be in my data set. Now, this group will include people who are under 20. And so, although I'm going to have everybody in my data set who went to the MEC, some of those people I don't want in my model. And so what we're going to actually create is we're going to create a new variable, and we'll call it something like include. And it's going to have two values, 0 and 1. And 0 is going to indicate no, and 1 is going to indicate yes. And so what it will be is all of the individuals who are in your data set that you want to include in your model, you're going to give them a value of 1 for this variable include and a value of 0 on the variable if you want to exclude them. So I'm going to make a couple of different exclusions of people who went to the MEC. One of them is I'm going to exclude people who are less than 20 years old. And the other exclusion I'm going to make is I'm going to exclude anybody who has missing data on any variable that's going to be included in my analysis. And so that's what I'm going to do now is I'm going to create this variable that will mark those individuals who I want to be in the model and those people who I don't want to be in the model. And those people that I want to not include in the model will be those under 20 years old and anybody who has any missing data for any variable in my model. So let's go ahead and do that. So here I am in the SAS program again. And the first thing that I want to do is I want to make sure that I have all of the variables that I need. Now, if you are using the interview group or the interview and MEC group, then you can use this variable from the data set that's called RIDSTATR. And this tells us whether they were in the interview only group or the both interview and MEC examined group. If they're in both, then if they did both rather, then they're coded 2. So if you're using either of these, then you want to make sure that you have this variable in your data set. Now, I had mentioned before to include this variable in your data set, so it should be there already. It comes from the demographics data. If you didn't put it in before, you can put it in now. Now, the other variable that we need is the weight variable. So if you're using, again, the interview only or the both interviewed and MEC examined group, your weight variable is going to be in the demographics data set. Now I'm using the MEC group, so my weight variable is going to be this full sample 2-year MEC exam weight. So I'm just going to grab this from here and I'm going to include it in my data set. It's from demographics, it's in both cycles, so I have to put it in both places. And so this should bring in all the variables that I need. Now, if you are using a subsample, for example, the fasting subsample or maybe the urinary environmental contaminant subsample, you should grab the weight variable out of the data set that corresponds to those data. So the next thing that I want to do is I want to limit the data set only to those people who are coming to the MEC for an examination. And so I'm going to do this way at the very bottom of the SAS program. So right before I write to the hard drive, this is where I'm going to limit the data and create the variable called include. So I'm just going to put a little label here. So I'm going to say limit data set and create include variable. So this is going to be data, work, data, set, work, data. And I'm going to use an if statement here to limit it only to those people who went to the MEC. So I can use this RIDSTATR variable. If it equals 2, then they went to the MEC. So I'm going to say if RIDSTATR equals 2, and then I'm going to have run. So let's just run this and see how many people we get. So let's check the log file first, see if everything looks blue. Looks like everything is running okay. I haven't changed things very much, so I don't need to check it too closely. But here we have where I'm limiting the data set. We start out with 20,686. After the limitation here, it goes to 20,015. So this should be equal to the number of people who went to the MEC in my 2 cycle years. So let's do a little calculation here. So let's see, this is what, 2007 and 8. There's 9762 in this year. And then in the 2009 and 10, there's 10,253 plus 10,253 equals 20,015, which is what I had here, 20,015. So it looks like it's correct. It's giving me all of the people in my 4 years of NHANES data who went to the Mobile Examination Center. Now, if you are using one of the subsamples, then to find the correct group of people, what you should do is you should go to the data file that contains the variable that is only collected in that subsample. So for example, if it's the environmental contaminants subsample that you're using, then you should go to the environmental contaminants data set because that's where you're getting the variable for your environmental contaminant. And what you can do is you can take the weight variable, and out of that data set, those individuals who have a non-zero value for the weight variable in that data set, those are the individuals who should be included in your data set. Now, the next thing that I want to do is I want to create the include variable for those people who are going to be in my model. And so I want to make sure that they have complete data on all of the variables in my model and they're of the right age. So let me first remember what variables I have in my model. So here is a shorthand version of my two models that I wrote before. So my linear regression model has the FEV1 to FVC ratio, which is a continuous variable. Years of smoking and age are continuous variables, and I have income, sex, race, and education as categorical variables. And my COPD logistic regression model is the same over here, but it has the categorical COPD variable as the outcome. Now, just as a reminder, what I'm trying to do is I have already limited the data to those who went to the MEC. So now I want to create this variable called include, which is going to be yes if the individuals are 20 years or older and they have complete data on all of the variables in my model. Okay, so to do this, I could just simply use an if then else statement. So we just have to make sure all of the conditions are in the if part of the statement. So this starts out with if. Now, the first one is I want to have the age limited to 20 years and over. And my age variable is up here. I've already taken the age in months and divided by 12. So age is the age in years. So I'm going to say if the age is greater than or equal to 20 years, and now let me work on the FEV1 to FVC ratio model first. I'm going to have two different include variables. You'll just have to have one because you have one model, but let me do mine one at a time. So for the FEV1 to FVC ratio, we need to have non-missing data. So the variable for FEV1 to FVC is here. So let me just copy and paste it. And so I'm going to say if FEV1 to FVC ratio is not equal to missing. So this symbol here, the caret with an equal sign, that means not equal to. So if FEV1 to FVC ratio is not equal to missing, and then I need all of the other variables in my model. So the first variable was the smoking, the years of smoking. So where is the variable? Here it is. So the variable for that is smoked underscore years. So I'll just take that. And I'm just going to do this for all of the variables in the model. Now, I just sped that up on the video, so I don't actually type that fast. But here I have the outcome variable. I have all of the covariates. Age was one of my covariates, but I'm using it also to limit the data set to an age group. So certainly everyone who has an age of 20 years or more will have non-missing data. So if all of these conditions are true, then I'm going to say include equals 1. and then else include equals 0. So this is what you can use. Since I have to have two different include variables for my two different models, I'm going to distinguish them. I'm going to say this is for the COPD model. Oh no, this is not the COPD. This is the FEV1 to FVC ratio model. So this will be the, let me call this FEV1. And this will be include underscore FEV1. So I'm going to create another include variable for the COPD model. It's basically going to be the same thing, except now instead of the FEV1 to FVC ratio being non-missing, I need the COPD variable to be non-missing. And I'm going to call this include COPD. Now let's see what how many people I have in each of these groups. So for my FEV1 to FVC ratio model, I'm going to have 7,072 individuals. And for the COPD model, I will have 7,338 individuals. Now, if this was a real analysis, I would be doing an analysis of where I was losing all of these people, which variables were causing me to lose these people, because we would report that in the manuscript, but we're not going to worry about that step here. Okay, so let me comment out this. Actually, let me erase this here. So the next thing that we need to do is we need to change the weighting variable that we included up here. For me, it was the weight MEC 2-year, the 2-year weight variable. We need to change it into a 4-year weight variable because we are combining 2 cycles of data together. So that's 4 years of data altogether. And so it's a very simple calculation when we're doing this. I'm going to do it in the step before when I limited the data set. So I'm going to put a new label here. I'm going to say create 4-year weight variable. It's going to be data, work data, set, work data. And to do it, you just divide, to get the 4-year weight variable, you just divide the 2-year weight variable by 2. You cut it in half. So I'm going to say, let's see, what's the variable name? Let me copy and paste it from here. I'm going to call this the weight MEC 4-year equals the weight MEC 2-year divided by 2. So that's all we have to do there. And the last thing that we have to do is we need to include some additional variables into our data set. And the data come from the demographics data. And this will be for everyone, no matter where you get your weight variable from. And what we want to include are these 2 variables here called the masked variance pseudo-PSU and the masked variance pseudo-stratum. So I'm just going to copy and paste both of these variables into my SAS code. And I'm going to include them from the demographics data sets. And so you should do the same. So these variables are going to be important for the SAS program to be able to analyze the amount of precision accurately that we have in our estimation procedure. So because we've not selected individuals using a simple random sample, the calculation for the amount of wobble there is in the estimates, if we were to repeat this study design again and again and again, that analysis uses a different kind of calculation that requires these 2 variables. So we're just going to put these 2 variables into our data set. So these are the things that we wanted to do. We wanted to create the include variables. We wanted to limit the data set to the right individuals. I've limited it to those who went to the MEC for the examination. Yours might be different. Of course, the variables in your model will be different. Your age range is probably going to be different. And then we wanted to calculate a 4-year weight variable by dividing the 2-year weight variable by 2. And we wanted to make sure that we had these two variables in our data set to allow for the proper estimation of the precision of our parameter estimates. So that should do it for this step. So hopefully you'll be able to do this for your data set as well.